Hi students, this is Mr. Yang. Today we're going to talk about 2.12b, where we will learn more about absolute value inequalities and some special cases. First, a quick review. In order to solve absolute value inequalities, we are still going to follow the same rule based on the signs. So if the inequality symbol is less than or equal to, it means and. If the symbol is greater than or equal to, it means or. And the definition for absolute value is still the same as last time, it doesn't change. Absolute value refers to the distance, and it's about the distance to 0. And a distance can never be negative. It has to be positive. Now, based on that definition, we have some special cases that we can think about. Let's say we have this absolute value, which has to be positive, and the first case is less than or equal to a negative. Of course, that would never work, so that's why it's no solution. Or let's say the other case, you still have this absolute value, which is going to be a positive number, and we're saying it's going to be greater than or equal to a negative number. Well, that of course is always going to be true. That's why the answer is all real number is always going to be true. Now let's start solving some inequalities. Example 1. First thing we need to do is to subtract the 2 from both sides. You can also choose to multiply the 4, but then you need to make sure you multiply the 4 on every single thing. So if we subtract 2, we are going to get 3x plus 3 over 4, that is greater or equal to 5. Then we're going to multiply both sides by a 4, that's going to give us 3x plus 3, that is greater or equal to 20. This is a very important step because this is the isolation step. Typically, it's right after the isolation step you start settling your cases, or in this case, you might actually decide if it's a special case or not. For this specific example, there is no negative number on the right side, so we're going to keep going to split the cases. So case 1, keep everything to normal and just copy everything down. Case 2, 3x plus 3. Reminder, for case 2, since it's on the other side, on the left side of the number line, we are going to need to flip the sign and flip the number. The first one after solving is going to give you x is greater or equal to 17 over 3. Second one after solving is going to give you x is less than or equal to negative 23 over 3. So 17 over 3 right here, pointing to the right, and negative 23 over 3 is here, pointing to the left. Something forgot a little bit. Because the sign is greater than or equal to, the connection word is or. That means we're going to keep everything, and we're going to shade everything. So final answer, now x is less than or equal to negative 23 over 3, union x is greater or equal to 17 over 3. So that is the final answer. Now example 2. The first question we're going to ask is it isolated? And yes, it is. So we're going to just have a look at the whole thing already. The right side is a negative number, so we can clearly see absolute value cannot be less than a negative number, so the answer is automatically no solution. So you see, after the isolation step, we just can decide about its special case already. Because it is no solution, there's nothing to graph. Now next, example 3. Well, this one, the left side is already isolated, so we can start by separating the cases. Case 1, 3 minus 5x over 6 less than 3. Just copy everything down. Case 2, 3 minus 5x over 6, flip the sign, greater than, flip the number, negative 3. And because the sign was a less than, that means it's going to be and as a connection. Now we're going to solve for each case. Multiply both sides by a 6. We got 3 minus 5x is less than 15. Move the 3 over. Negative 5x is less than 15. Divide both sides by the negative 5. Remember to flip your sign. X is greater than negative 3. The other one, 3 minus 5x is greater than negative 18. So negative 5x is greater than negative 21. Divide both sides by the negative 5. Flip their sign. It's going to be 21 over 5. So let's say negative 3 is here. 21 over 5 is on the right side. And since we're looking for and, I write the word again, and That's why we're going to shade the middle part. Final answer, -3 is less than x, which is less than 21/5. That is example 3. Next, example 4. First, we're going to see, the question is not isolated. The absolute value is not isolated. Because it's multiplied by 6, I'm going to divide both sides by 6 first. So I got x/5 plus 4. It is less than or equal to 0. 0 is not a negative number, so I'm not going to just say no solution or all real number. We're still going to need to separate the cases. It is a little bit special about the case. The first case, we still keep everything. However, the second case is going to be slightly different. We are going to still need to flip the sign. Just in this case, when we flip a number, the 0 is still going to be a 0. Because in the previous step, we got less than or equal to as the sign, the connection word is and. First one, after solving, x is less than or equal to -20. Second one, after solving, x is greater than or equal to -20. And don't forget, the connection word is and. Now let's graph each and see what we're going to get. First one, -20 pointing to the left. Second one, -20 pointing to the right. Again, because the word is and, so we are looking for overlap. This is the only point they actually overlapped. So the answer is x equals -20. If I change that question from an inequality sign from less than or equal to actually less than, the answer would actually be no solution. Moving on, example 5. Subtract 6 on both sides. We got 4y minus 3 is greater or equal to -2. Again, this is the isolation step where we are trying to get the absolute value by itself. And now we can actually decide if it's a special case or start separating the cases. The right side is a negative number. An absolute value is always going to be greater or equal to a negative number. So the answer is automatically all real number. However, something you might have missed, all real number does have a graph. We are going to need to draw a line and we are going to shade every single part on the line because that's how we indicate all real number. Now number 6, I'm going to add 9 on both sides. So we got 7, then n over 3 is less than or equal to 21. Then we're going to need to divide both sides by the 7. We are going to get n over 3 is less than or equal to 3. Case 1, just copy it down, less than or equal to 3. Case 2, greater or equal to -3. And the connection word, because it is less than or equal to, is going to be and. So the first one, after you finish solving, it's going to give you n is less than or equal to 9. Second one, n is greater or equal to -9. So -9 is here, pointing to the right. 9 is here, pointing to the left. We are looking for, again, the connection word is and. So we're going to shade the middle part. Final answer, -9 is less than or equal to x, which is less than or equal to 9. That is example 6. Next, example 7. Subtract 6 on both sides. We are going to get 3, then 1/2 y plus 2. Less than 9. Then we got divide both sides by the 3. We're going to get 1/2 y plus 2 is less than 3. We can start separating the cases. Case 1, copy it down, plus 2 less than 3. Case 2, y plus 2 greater than -3. And if you're like, why did you subtract 6? Why didn't you divide by 3 first? You can choose to divide by 3, but then you are going to need to make sure you divide by the 3 on every single thing. Now next, I'm going to subtract 2 on both sides. So 1/2 y is less than 1. Multiply both sides by a 2, y is less than 2. Subtract 2 on both sides. 1/2 y is greater than -5, so y is greater than -10. And here's the connection word because it is less than, so the connection word is and. Now I can start graphing. It is less than 2. It is greater than -10. Since the connection word is and, I'm going to shade the middle part. Final answer, -10 is less than x, less than y. which is less than 2. Next, number 8. Subtract 3 on both sides. For 3x plus 7, which is greater than negative 1. Then divide both sides by a 4. 3x plus 7 greater than negative 1/4. This is my isolation step because my absolute value is now by itself. And I can see the right side is a negative number. So automatically that's going to work, always work. So the answer is all real number. You just need to make sure to graph and shade every single part on the number line. That is everything for 2.12b. Thank you.